Hello, this is Shobhan again, and this is my StarHive MQTT IoT node project. Well, you can see it here. This ESP8266 here is controlling the Arduino Nano. The Arduino Nano is acting as a not so cheap but quite cheap port expander that has ADC bidirectional GPIOs and things, and this is a very stylish flower tub, well, kind of worn out, and this is the soil moisture sensor, and that's the amplifier, and it's hooked to the analog pins of this Arduino Nano. And in order to stop the sensor from corroding very fast, I have actually connected this amplifier module's VCC to a GPIO of this Arduino Nano so that I can turn it on and off whenever I want. You might say you should have added a MOSFET or something. Well, it works for now. If my Arduino Nano dies, I will just then add the MOSFET. Okay, so what it's doing is it is sending the data from this sensor every 30 seconds to my MQTT broker, which is running in this server over here. Yeah, it's a NanoPi Neo based Linux server, and this is also my print server, and for the sensor network purpose I call it the Central Hive, or in a more stylish way, Hive Central. Okay, so this is the power brick. I mean, this one 12 is feeding 12 volts here, and it's running the node, but this node should run just fine on about 7 volts. Alright, let's take a look at the code. Well, at first there is a definitions.h file, and here are the libraries. Yeah, I know I could have used the pubsub client library, but I just didn't. Okay, and the wire.h is not in this defs.h as like the other libraries because my code is messy. Okay, so let's actually look at it from the beginning. This is the setup serial.begin. Then I am disconnecting the Wi-Fi and I am beginning it because I have seen that sometimes it fails otherwise. And then this standard thing, and then I am initiating OTA, which is this function. Yeah, I am using a host name. My sensor network name is StarHive. Actually, it's taken from the fact that I am using it like a star network where everyone is posting to the MQTT broker, which is at the center, and everyone is getting information from it, so it's a star. And yeah, I like the word hive, so that's a StarHive. Okay, and then just I'm getting the chip ID and doing stuff, and yeah, I'm obviously setting a password because I don't want some villain to turn my innocent sensor node into a violent flesh eating monster or something. Okay, and then these are the standard stuffs, and here is a function I have written, prepare for OTA. It will always hold the functions which are needed to turn things off or put them in a safe position. For example, if I have made say a water pumping system, then while the code is being uploaded, I don't want the pump to run, obviously, and things like that. For now I'm just turning my sensor off, and the MQTT, well, I don't think it's necessary. I was just frantically trying everything when my OTA didn't work. Okay, and this is a handle Wi-Fi things function. It just runs in the main loop. If the Wi-Fi gets disconnected for some reason, it will continuously try to connect. That's it. And it's the void loop. Okay, that's OTA and things. And I actually learned something. Actually, I kind of knew it, but had to try several things. That the OTA won't work if I put a huge delay, because my sensor turns on for 2 seconds, then the data gets uploaded to MQTT broker, and then everything then it disconnects and waits for about 28 seconds, so that's 30 seconds. But in that 28 second nothing actually works, so this Arduino OTA won't work as well. So I actually used millis to create an artificial delay, and yeah, I might have been able to write it better, but I just tried and it worked. Okay, so there's a flag if that huge delay has been initialized. If it hasn't, then it does this. It connects to MQTT. It turns on the sensor. It waits for 2 seconds. I've written it as just one function, but I was actually frantically trying everything to get my OTA working, so I thought dividing them into small parts would work better, which actually didn't, obviously. And then this is reading the analog grid, and yeah, obviously I forgot to tell you something, that this is not the analog grid of ESP8266. It's a custom library function written by me so that it could talk to this Arduino via the I2C bus. It actually literally using this Arduino Nano as a port expander, which has many ADCs, PWMs and stuffs, and all of them are 5-volt compliant. So yeah, these sensors are, I mean, I can hook up sensors more comfortably in that Arduino Nano and not TSP. Okay, and it's just publishing and doing its stuffs, and then capturing the start time and delay initialize. And when everything is done, and when this it gets the delay in it true, it will actually move to this part, and it will actually check if 28 seconds have passed. I mean, I am recording this start time at the end of loop, then I am initializing the delay in it. So this time this stays where what it is always, and this millis keeps on updating, and if it finds a 28-second delay, it just turns the delay off. Okay, and this MQTT connect has been copy pasted from Adafruit's example. That's all. Okay, that's what this code actually doing for now. And yeah, it's obviously OTA supported, so let's do some OTA. As you can see, it is actually not connected to any serial port. It's connected to this host name at this IP address, which is my ESP8266. Let's try compiling things, and yeah, it's actually attempting to upload. This upload sometimes might fail, then you just have to actually the password, and yeah, now it's uploading the code. It took some time for the authentication thing, and yeah, I think the code has been uploaded, and lots of terminals there, and this terminal is running actually a Python code which fetches the data, and yeah, it's updating this flower tub SMS1. That is the name of the MQTT topic which is written here, and yeah, this is the ADC value. This is the number of data it has captured so far, and this is just the timestamp. Alright, that's all there was to it. I'll post the code soon. So thanks for watching.